Hello, everybody. Welcome to General Chemistry 2, the lecture component of Chem 1200. I'm Patrick Lloyd, and welcome aboard. Now the semester has begun. The summer module, I should say, has begun. So we have 6 weeks. We're going to go through the end of July and into very early August in this course. So it's time to get started. So what I'm going to do, just to kind of get us going, is let me bring this up here. Oops, sorry, hold on a second here. There we go. So I'm going to bring up the bright space um, shell for your course. And so what you'll see here, your S51, remember that Professor Mackenzie is handling the laboratory components. So you should also have an S51L shell in your bright space. So make sure you check out for that one as well. So the lecture syllabus is right here. The video links, these are links to each chapter of the material that we're going to cover. And then here are some lecture materials as well. So I'm going to go ahead and bring up the syllabus. Okay, so if you take a look here, again, here's my contact information here. We will be having virtual office hours on Zoom on Tuesdays and Thursdays. I will say this, be careful if you feel like you're going to come to one of the office hours. It's not a bad idea just to text me, send me a text message just to remind me that you're going to be there. Because when I'm in my office, I'm doing things, and if nobody is logged in to it, then I get distracted. People come into my office and such. So just send me a quick text if you think you're going to come. And the contact information for that Zoom meeting is the meeting ID is right here, 761-534-4943. And the password is MEET, MEET. Okay? So we're going to start on kinetics now. So chapter 14 is kinetics. Again, you have a long time to do it, but let's remind ourselves, I made this in an earlier announcement. You want to definitely stay up on this. My advice would be to finish chapter 14 kinetics within a week. Do it within a week and then move on to 15. Do that within a week, so forth and so on. That also goes for the exams. So you'll do the exams and the homework. And if you have problems with it, reach out to me. We can go over some of this stuff. Hopefully by now you've registered for the ALEKS, ALEKS. Again, don't use that you need to wait to payday as an excuse to buy it. You have 2 free weeks of access to it. So make sure you get started on this. You really want to get going. Again, here's all the login information. The most important information is the class code, right? Okay, so go ahead and get started on this stuff on the kinetics. I'm going to try to continuously throughout the semester, throughout the summer, adding more videos that are connected more directly to the ALEKS, for some of the ALEKS solutions. Okay, so let me show you also. I'm going to come back here in just a second and bring up over here video links. So let me share this one right here. Okay, so here are video links. So here's a video discussion of the syllabus. Here's a video discussion of ALEKS. Again, with the ALEKS, be careful. The codes that are indicated in that video are older codes from a previous course. So make sure you use the codes the code, I should say, the course code that is associated with this class, which is in the course syllabus. Okay, and then chapter 14, this will link you to chapter 14 to the videos there. Okay. I'm going to come up here and see if we can now see the chapter presentations as well. Okay, I've put the first couple of them up here. Chapter 14, the kinetics lecture. So let's bring that up. Okay, so this is typically more useful for someone when they're in the classroom, but it also has an introduction and some sample problems to some of the material that will help you get ready for doing the ALEKS problems here. So here's chapter 14. I will put up chapter 16, 17, 18, 19, and 20 later on there. Okay? So just briefly, here's the deal with kinetics. Kinetics is the study of how fast reactions occur. And it turns out that studying the speed of a reaction allows us some insight into how chemical reactions are occurring. So we do something very simple. We just measure how fast the reaction occurs. If we know the concentrations of the reactants and we can control for that, that allows us to be able to make some pretty interesting predictions and studies of chemical reactions. It turns out that the field of kinetics is related to structures of molecules, so it gives us some insight into how molecules are interacting with each other when they collide and when they react or whether they don't react. So it gives us some insight into reactions. Okay, so here's a reaction that we often do in the laboratory where you essentially just use a stopwatch to see how long it takes to change color, and then you can gain some insight into that. So one of the things you'll notice is there's some graphical aspect in this discussion. So there's some graphing. When you look at these graphs, pay attention to the axes, right? This is the x-axis here, time in seconds. So that's kinetics, right? You're measuring something in time. This is the number of molecules of the reactants going down and the products going up, right? Over time, the products are going to increase in their numbers. The reactants are going to decrease in their numbers. So this particular graph is an important one. What it shows you is there's a relationship between how fast the reactants are used up and how fast the products are generated. Okay, so high concentration, the purple ones for the reactants, decreasing over time. Low concentration of the products increasing over time. And then we turn it into mathematical equations. You'll see this notation throughout. This little symbol here is the Greek letter delta, which means change. You should have seen this in the previous course, General Chemistry 1, when you did enthalpy changes or temperature changes, right? The delta means a change in. So we would read this sentence as rate, the speed of the reaction, that's what a rate is equal to the change in, notice this bracket notation, the change in the concentration of the A, which is the reactant, A is typically a reactant, divided by the change in T, where T is time. Notice there's a little negative in there. By making that a negative, that makes the rate positive for the reactants. And you can measure this by just taking a final concentration of the reactant and subtracting from that the initial concentration. That would be the change in concentration divided by the change in time, the final time minus the initial time. So that ratio turns out to be the slope between 2 points. So if I were to take this point right here and this point right there, the change in the concentration, well, here's your final concentration, here's your initial. So initial's right there. Final concentration would be right around there. And then here's your final time. That looks like 30 seconds. Your initial time would be 20 seconds. So change in time would be 10 seconds, right? That change in concentration divided by the change in time is really, it's just the slope of a line going through those 2 points. So you'll look through that. You'll do some ALEKS problems on that. If you have difficulties with the ALEKS problems, get in touch with me. I can go over 1 or 2 of them with you. Remember, you also have access to tutoring through the library online. Okay, here's another curve. This is reactants decreasing in the concentration over time. Okay, reactants decrease, products increase. Okay, so that's just a brief little intro. You'll get into it. Again, I have videos for the different sections. I just wanted to give you a little broad overview of what you're looking at. It's an important chapter. It's a challenging chapter. There's some mathematics in it that may really push you on some of this material, but you're up to it. If you put the effort in, you can do it. Okay. So that's my little brief intro for today. So I should have another announcement for you coming up probably on Thursday or Friday, one of those 2 days, and then we'll keep going from there. Again, reach out to me if you have any questions. Start working on the Alex problem. Start watching some of these videos. And again, don't forget that you got your laboratory professor, Professor McKenzie, as well. So take care.